Okay, second question, right? A train is moving horizontally, and it slows down from this to this at a constant rate of this. So if you use Suvat rules, you know that this is U, this is V, and this is A, right? Since it slows down, to be precise, A is -2. Then they ask you what's the distance, so you can actually use V squared is equal to U squared plus 2AS, and you in fact get the correct answer. But in this case, I want to talk in terms of the velocity time graph to illustrate how powerful the velocity time graph is if you didn't even know the Suvat rules. So velocity time graph, the initial is 66, and it slows down at constant rate meaning that the gradient of this velocity time graph is constant. It slows down until 22. So it slows down here until 22, and we know that the gradient is -2, right? So the gradient is -2. Time we do not know. And we want to find the distance that it travels. So the distance that it travels is going to be the area of this region over here. So we do not know the time, but we need to kind of know the time, because in order to find the area of this trapezium, we need to know what's the base. So the base in this case, let the time be t, and we can express the time t in terms of the gradient and the numbers we're given. So we do know that t is equals to 66 or 22 minus 66 over -2, and this is -44 minus 2, so this is 22. So now we know that t is 22. Then from there we can find the area of the trapezium, which is given by area. So the area is the distance that it travels, because the distance that it travels while slowing down is the integral of the velocity, which is the area under the velocity time graph. So area is half times the base is 22, which is this thing, times the height, times the sum of the heights, which is 66 plus 22. Let me calculate this out. Half times 22 plus 88, 968, which is approximately D. So the answer is D. So you see that we could have used Suvat rules, but personally, I like using the velocity time graph a lot, because it's very illuminating, and there's almost no confusion about things like sign differences. If your velocity time graph goes to the negative, right, it might get a bit confusing whether your A is a negative or your V squared is 2AS. You need to be careful with all those. But if you use the velocity time graph, everything is clear, and you don't need to memorize anything as well.